discussed, were you able to hear me, right? In the last class, we have everybody able to clear see the screen?
Yes, sir.
Okay. So in the last class, just a little introduction of the Shear Center already, and I will go a little quick on the Shear Center. After that, I will discuss about the uniform torsion. This topic is uniform torsion. So here, just Shear Center is very important because sometimes they are asking every almost the last 2-3 years they are asking on the Shear Center topic. So this is very important. So, but little bit students will have little confusion about the normal centroid and shear center. So just I wanted to give a little clarification on that confusion. So shear, what is the shear center is? Suppose you feel, suppose this is the one beam. Suppose any cross section of a beam, if you divide that cross section into two equal parts by providing two equal parts, then that's a section we call it as a symmetric section, right? So any section, if you wanted to can able to divide the two equal parts from the center, we cut the line at the center. If both are two equal parts, then obviously that will be considered as a symmetric section. That's what we call it as a symmetric section. Suppose if you see, this is the example of the cross section. It is the C, inverted C. We can say there's inverted U, or we can say. So this is the steel profile section. You see, this is the, if you if you cut the section at the center, obviously it will divide it into two parts. So that means we call it as symmetric about this vertical. That's what we call it as vertical. So suppose if any section we can able to symmetric about vertically, then we consider the centroid, the shear center passing through its centroid. So if anything, any section, cross section, symmetrical section is there, then obviously it's the center, shear center and centroid will the same point, right? Please remember. But suppose this unsymmetrical section, if you see the same C is the same U is turned into 90 degrees and became a C section. This is a cross section. So cross section means if you see from the front, you can appear this C. Earlier it is U, now it is C. But if you see, you cannot able to cut the section into two equal parts here. Then we call it as a unsymmetrical section. So such sections, what happens is the centroid will not coincidence with the shear center. So shear center is not coincidence with the centroid of the centroid is here itself. Even though it is unsymmetrical, the centroid will be here for this section. But the shear center may not be able to coincidence with the centroid. But if you here in this section, even though this is a symmetrical section, so in this section centroid will coincidence with the shear center. That means coincidence centroid is the same and shear center are the same for this point, this cross section. But whenever this unsymmetrical section, centroid is anyhow here, but shear center may not able to here. It may be here somewhere, but along the same axis, but it may not at the same point. That we call then we call it as unsymmetrical section. So then, what is exact definition of the shear center? Sometimes in the based on the definition, they will ask the question. Shear center of a section is defined as the point through which the load must be applied to produce zero twisting moment. So suppose there is a point here, the load is exactly passing through the shear center, then there should not happen any twisting moment. Movement will happen, but please remember, many students will confuse between the normal moment and twisting moment. Normal moment is nothing but bending of the beam. We call it as a, due to that bending, we call it as a moment. But twisting moment is nothing but twisting is, suppose this is a beam, the load is applied at the here, this is a fixed end, it will try to bend in this direction. But this force is applied here, this force into perpendicular distance, we call it as moment. But this happening is bending is happening due to this moment. But that is normal as normal moment. Twisting moment is nothing but this is also moment, but the beam will be twist like this. Please remember, this is the twisting and this is the bending. Please remember, there is a clear difference between the bending moment and the twisting moment. This is the bending moment. The beam will try to bend. Initially it is straight, it is bending. But twisting means twisting moment will happen, it will be twist. But please remember, it will be twist. This is the twisting moment. This we call it, but both units are the same. This is the twisting moment and this is the bending moment. But the load is applied exactly here, it will try to bend in this beam. This is bending moment, and it will, suppose the beam is happening like this, then we call it as a twisting moment. Please remember, this is very important topic. Many of even the faculties also might not know and visualize properly what is the bending moment, what is the twisting, what is the twist moment and bending moment. So please remember this concept, very important. Even in the future also, bending, both are units are the same, both we call it as a moment only, force into perpendicular distance. So but due to this normal moment, what happens if beam try to bend, the load is here, but due to the other twisting moment, that beam try to twist, right? It is clear. So this is the twisting moment. But come back to the shear center concept. If you know, when the load is such that if the load is passing through the, if the load is passing through the, if the load is passing through the shear center, there should not be twisting, not at all happens, right? But movement will happen, but twisting will be zero. That type of property we call it as a shear center, please remember. So we'll go one more, then we can see here. Generally beam has two axes, that is the shear center coincided with the centroid. If the beam is symmetric about one axis, then we shear center may not able to exactly same position of the, suppose the axis of symmetry is unsymmetrical section, shear center will not coincidence with the normal centroid. If the load passes the shear center, there will be a only bending stress or bending moment will be there. If the load is applied exactly at the shear center, there should not be a twisting, only bending will be there, but there is no twisting if the load is passing through the shear center. Please remember, and we will go a little bit other yes. If you see, just now we discussed about the unsymmetrical section, that is unsymmetrical about the vertical. Please remember, it is symmetrical about the horizontal axis. That means the shear center also acts at the any time anywhere in the horizontal axis, but it is unsymmetrical about the vertical axis. So that's why the shear center may not lie in this plane, in the vertical line of the symmetry. It may be somewhere outside or inside, that we will check it out. But for particular C, the shear center will happen outside of this C, not the inside. Outside along the same line of horizontal axis, somewhere here it will be happen. This somewhere here we can see this is, but this line is the same, right? So that is the shear center for this is very important property, and especially many times asking for the C. Shear center will be not at the exactly line center of this one. But how we can able to find the shear center? We can use this formula that I will come back again. Last class we discussed, again we will come back after the one gate question, right? So yes, so these are the some typical types of the shear centers of different cross sections of the beam, right? This I have taken from the STAD Pro software. This is not there in any textbook, but this is there in the software also. Software also very important. It will ask the shear center location, because if the shear center is the symmetric axis, then the shear center is passes through the centroid. If you see the cross section is circle, obviously this is symmetric, then it will be passes through the centroid. Please remember, I'm talking about the vertical symmetry only, not the horizontal symmetry here, right? Then it will be the pass through centroid. This is a rectangle also the same. That way, but if you see the C channel section, centroid is here, but shear center is here, because if we cut the section in vertically, it is not symmetrical. It is unsymmetrical section, right? C is unsymmetrical about the vertical axis. If you line rather line way here, they may not divide that parts into two parts. That we call it as unsymmetric, right? So C is unsymmetrical. That's why shear center will not coincidence with the centroid. So this point is centroid, this point is shear center. But remaining all are the same. Centroid is same and shear center is same. So that's why you cannot able to see two different colors of these points. So wherever the one single, that is nothing but centroid and coincided with the shear center. But particular case C channel, centroid is different, shear center is different. But if you see the next I section also, if you divide is vertically, it is a symmetrical section. So that's why it is passing through the both centroid and the shear center is the same location. With the T section also, if you divide this vertically, it is the same. So that's why centroid is coincidence with the shear center. And the same is Z section. Centroid, if you draw this section, we will get the same different shapes. Also same, if you divide this vertical axis, we will get the symmetric in the. So, but please remember, if a load is passes through the line of action of the shear center, then there should not be any torsion over the section. So that is the clear. And please remember, this sometimes they asking the bits like a theory also. Suppose the shear center is passes through the, when we call it as a shear center, the load passes the load, the point of the load, which the shear center passing through that load, there should not be any torsion happen in the beam.